Come on, baby. Give me a good one. Woo! All right. That's what we're going to work with.
All right. So can everyone hear me? Perfect. Okay, so we're going to be working on the 2023 problem number 3 FRQ, because that's actually what we were given. So let me pull over the first part. The first part is going to be, let me pull up the problem. It's the whole problem itself. And we can read together and we can go over it. So it is going to be, a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of milk at the time t, where m of t is measured in degrees Celsius and t is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation. Dm over dt is equal to 1/4 40 minus m. So this right here is already the derivative. So the first derivative of the actual equation of m relating to t is going to be 1/4 40 minus m. At time t is equal to 0, the temperature of milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Okay. That means that what they're defining here is that there's going to be an asymptote at 40, and that is shown right here. A slope field, this is the given slope field. Sketch a solution curve through the point. Okay, so what we can do is we can actually, let's change color real quick. Okay, so we know that the point 0.05, so what we can do is we just got to follow the line, so we know that this thing's going to go right. Actually, I don't like this color. Let's go this color. No, that's the color, just fine. Let's go this color. Yeah. Okay, so we know that this is right here, and we can see we can just follow that line like that, and we can just keep following, but it says it'll always be less than 40, so we actually have to make sure that it never touches 40. It's pretty simple. It just never touches 40, and it follows something like that. So that is going to be part A. And now let's move on to part B. Use a line tangent. Let's move actually this thing out of the way. Now for part B, use a line tangent to the graph of m at t is equal to 0 to approximate m of 2. Okay, so what they're saying is they're going to say that using this line right here, that is tangent, so they're saying the slope is going to look something like this. So at this point right here, whatever line that is, they're trying to say estimate the actual point for the milk, like how hot the milk is at that point. So what we're going to do is we're going to take the equation. So dm over dt is equal to 1/4 and then 40 minus m. So this is the derivative. This is finding the slope at that point. So what we can do is we can actually use we can use this equation to find the slope at that point, and then what we can do is after we find the slope, we can use the points given, plug it into the point slope formula, and then that would be our line. And then we plug in the point 0,5, and we find whatever that approximation is. Okay, so what we do is now we plug in. Now for m, we actually know that at time t is equal to 0, m is 5 degrees. Since it shows 5 degrees Celsius here, that's what our m is. So it's actually going to be 1/4 40 minus 5, and that's going to be 1/4 of 35. And that is equal to 35 divided by 4. So this is our slope at that point of time t is equal to 0. Now we can actually plug it into the point slope formula, given our points. So we know our points is 0,5. We plug it into the point slope formula, and then we should be able to find it. So let me. So we know. Sorry, my head blinked. So we know that this 35 over 4 is equal to the y values on top. So this is going to be our m values actually. So this is going to be the 5 minus or y minus 5, and then it's going to be x minus 0. And this 0,5 is this point right here that we are given. That is the point at time t is equal to 0. That's the point 0,5. Now we can simplify this. So this becomes 35 over 4 is equal to y minus 5 over x. Now we can plug in xy for 2. We just gotta plug in 2 for x, and then we gotta solve for y. Our y is essentially our m here. So let me clarify, our m is equal to y here. Now if we plug in 2, we should get 35 over 4 is equal to our 2. So this is going to be our y minus 5 over 2. And then we can solve from here, where if we multiply this top by 2, so we can actually get 35 over 4 is equal to 2y minus 10 over 4. 35 is equal to 2y minus 10. 45 is equal to 2y, and y is equal to 45 over 2. So that means that 45 over 2 is our approximation for time t is equal to 2 minutes. So at 2 minutes, the temperature is 45 over 2 degrees Celsius. All right, so welcome back to my problem set. Right now, let's work on problem 3C. So let's look at it. A bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk at the time t is equal to 0 t. So this is the same problem. Let's choose a different color. We'll go red. All right, so our expression for this, so we just gotta find the second derivative, right? So let's take the previous one. So 1/4 40 minus m, and now we just gotta take the second derivative. So we gotta take we're gonna take dm over dt squared. Or just take the derivative of this thing normally. All right, so let's do this. So what we're gonna first do is treating it as if it was 1/4 x. If it was 1/4 x, then the first thing we would do is we would do the times. We would do it's just 1/4 times the derivative of taking the derivative of this would just equal to 1/4 times the derivative of x. So that's the same thing that's gonna happen here. So it's gonna be our 1/4 times the derivative of the middle. So times the derivative of 40 minus. So the derivative of 40 is gonna be 1 or 0, and the derivative of m is gonna be 1. So minus 1. Now multiplying by the derivative of m, since this is dm over dt and not just the prime, not just d over dm, it's in terms of t, it's differential, so it's actually going to be times the derivative of m, so it's actually going to be times dm over dt. Now, this is going to be the same thing as 1/4 times negative dm over dt. Now, to go to the next step, we can actually pull the original equation. The original equation is 1/4 40 minus m. We can actually pull that and we can substitute it in for that value right there. So let me pull out a brain color for this. All right, so we can actually take this value, take this equation right here, and we can substitute it right there. So that's going to be then 1/4 times the negative of 1/4 times 40 minus m. Now from here we can do a little bit of simplifying. We can do, so it becomes 1/4 times negative 10 plus 1/4 m. Now we do the same thing, and it becomes negative 10 over 4 plus 1/16 m. Now all we got to do is determine whether this is determine the approximation of underestimate or an overestimate for the actual value. So if the value of m is equal to 2. So to do this, we actually have to we just got to plug in So it says that since we're using the equation determining the approximation from part B, our part B was an equation that we came up with. Now, this is at the equation that we came up with in part B was actually the line tangent to m is equal to 0. So, or m is equal to 5. Now, let's see, if we plug in 5 over here, what we're trying to do is we're trying to figure out whether at 5, is it concave up, is it concave down, so that the line tangent, will it be above all values of the function m, or will it be below all values of the function m? So then what we're going to do is we can plug in 5 for this, and it becomes negative 10 over 4 plus 5 over, or minus 5 over 16. And this is obviously a negative value. Because it's a negative value, it doesn't really matter what it needs to be. It doesn't matter because that means we know that on the actual graph, let me pull up a different value here. On the actual graph, the graph goes concave down. So this means that it goes something like this. I'm just gonna estimate here, and then the actual line will look something like this. So at t is equal to 0, or at m is equal to 5 right here. At some point, it's actually gonna be, oh, that is not a good color to blend in the background. So it's actually going to look something like this. That's that line right there. And we use this line to approximate for m of 2. For time t is equal to 2. For time t is equal to 2, we use that line. We use that same line. We're trying to figure out whether it's an over or under. Because we used it at t is equal to 0, that's where we actually got the original point from. And then we look for t is equal to 2. It's actually going to be over. Since it only touches the actual point at one point, which is going to be over here, everything else is going to be over the whole function then. So this is actually an overestimate. This is an overestimate because it is concave down. Now, let's move on to part D. All right, use separation of variables to find an expression for this to the differential equation dm is equal to, okay, so we just got to use separation of variables. We're going to take the integral. It's that simple. We got to take the integral on both sides. So let's separate it out. Yeah. So let's actually use a different color for this. Let's use black. We actually use black. Oh, that's not black, but that's a nice color. So we get dm over dt is equal to 1/4 40 minus m. Now let's move it over to each side. So we get we can multiply this by 4. Actually, let's move this dt over here. Let's move this 140 minus m over here. So it's actually multiplying. So it's actually this is going to be the same thing as dividing this by this and multiplying this. So we multiply this by 4, or actually what we can do is multiply this by d over t, and it becomes dm is equal to 1/4 40 minus m dt. Now this obviously isn't going to work here because it's m and t are two different variables, and when we're taking the integral, we want it to be the same variable essentially. So we're actually going to move this over. So it becomes if we divide that by 40 minus m, this becomes dm over 40 minus m is equal to 1/4 dt. So it looks like we got the right side intact. Let's do the left side. So actually we got this side intact too. So it becomes 1 over 40 minus m dm is equal to 1/4 dt. Now we can actually take the integral of both sides to be able to separation of variables. We take the integral of both sides and we're trying to solve for the original equation. So on the left side, it's actually going to be ln. So it's going to be ln ln 40 minus m, and this is actually going to be negative ln because it's the when you're taking that ln, so you got to be able to count the other way. Is equal to, now 1/4 dt. This is just equal to 1/4 t plus c. There was originally a plus c here, and if we do the c minus c, it's just still some arbitrary value c, so we're just going to ignore that, and it's going to be plus c over here. Now, let's move this over. Let's move this over here. Now what we can do is, first, let's move the negative over. I don't like this negative, so it becomes ln 40 minus m is equal to 1/4 t plus c. Now, this is negative, actually. This will technically be negative 2, but see, again, c is some arbitrary value, so whatever we do to it, we can still continue calling it c. So now we can actually get rid of this ln. I hate the ln. Everyone hates the ln. No one likes the ln. You take everything exponent by e. So it becomes e to the power of ln 40 minus m is equal to e to the power of negative 1/4 plus t plus c. And then this becomes the absolute value of 40 minus m is equal to e to the power of negative 1/4 t plus c. Now, something that we mentioned was that the value of m cannot actually go above 40. So it is quite impossible for this to be negative. If we remember the slope field, it was something like this. It was actually I can just pull it up. The slope field was this. Now, if we remember, it says that the slope fields show that it goes like this. Goes like this, goes like this, goes like this, goes like this, but it never touches 40. So because it never touches 40, we actually know that this is impossible for this to be negative. I'm actually going to struggle here finding the exact color, so we're just going to choose a new color entirely. So we know that this cannot be negative. Because we know this cannot be negative, we can actually remove the absolute value using the logic that they gave us to in the beginning of the equation. So this becomes 40 minus m is equal to e to the power of negative 1/4 plus c. Now, this becomes significantly simpler. So they give us the initial conditions, the same thing that they gave us originally, where time t is equal to 0, m is equal to 5. They give us the original equation. We can actually just plug this in to find our oh, it's a t, by the way. We can actually plug this in to find our c. Our c is going to be a problem here. So what we can do is we can directly plug it in. 40 minus m, so we can do t is equal to 0. So when t is equal to 0, it's 40 minus m. All right, 40 minus 5, so this becomes 40 minus 5 is equal to e to the power of 0. T is actually 0 here, so it becomes 0 plus c. So it becomes 35 is equal to e to the power of c. Now, we actually don't need to solve for c separately. Because there's magic, okay? We're just going to leave it like this. We're going to leave it like this. And there's a reason I'm doing this, because what we're going to do is I'm actually going to, I'm going to put it in a different color, because there's a special reason. It's e to the c is equal to 35. So let's go back to our original equation. So it becomes 40 minus m is equal to e to the power of negative 1/4 t plus c. But when you add things here on top of the exponent, you can actually split it. So it becomes 40 minus m is equal to e to the power of negative 1/4 t plus e to the power c, or times e to the power c. E to the power c. But we know e to the power c. E to the power c is just 35. So what we can do is we can change the color again. We know this. We can actually take this from here and we can plug it in, and that will completely eliminate c. So what we can do is we can actually do 40 minus m is equal to e to the power of negative 1/4 t times 35. Now let's solve this to be a expression for m and t. So we got to s of m. So we gotta add m, and then subtract that. So it becomes 40 minus e to the power of negative 1/4 t. Oh wait, actually, pardon me. It becomes 35. 35 e to the power of negative 1/4 t. I can actually rewrite that in a different color. That might be a little easier for you to see, Mr. Taylor. Negative 1/4 t. And that right there, ladies and gentlemen, is the expression for m and t. Thank you.